Okay, guys, greetings once again, and welcome to another edition by iCampSA. In this edition, we are going to be looking at grade 12 mathematics. More specifically, we're going to be looking at the 2026 June exam, paper 2. And this is a paper that was written by learners which are based in Northwest. This will be part 1. Part 2 will follow. So let's have a look at these questions. Hopefully they are not too blurry for you to see. So let's have a look at question number 3. So question number 3 reads, simplify the expression below to a single trigonometric ratio without using a calculator. So let's go and look at 3.1. Okay. So with 3.1, what we are given is cos of 200 and then times cos of 90 minus x, and then multiplied by tan of x minus 180 degrees, and then multiplied by cos of, let's create some space, that is going to be cos of 540 plus x. Okay, that is what we have, and all of this is divided by, if you observe carefully, sine of 360 minus x, and then multiplied by sine of 110 degrees. Okay, so let's go ahead and deal with this. So if you look carefully, what I prefer is to always summarize or break down the problem into small bits by simplifying all of these on the side. So if, for example, we look at the first trig ratio, which is cos of 200 degrees. Cos of 200 degrees is the same as cos of 180 degrees plus 20 degrees. Okay? And we know that 180 plus theta is in the second quadrant. Sorry, 180 plus theta is in the third quadrant. And in the third quadrant, what we know is that sine is negative. So we'll end up having, what we know is that cos is negative. So we'll end up having negative cos of 20 degrees. Okay. And then we are going to look at tan of x minus 180 degrees. So we know that tan has the period 180 degrees. So this means I can say tan of 180 degrees plus x minus 180 degrees, and you will see that this and that will cancel, leaving us with the simplification where that will end up being tan of x. Okay, and then we can go to the next one where we are looking at, if you observe carefully, sine of 360 minus x. Whenever we're looking at 360 minus x, you should remember this is the fourth quadrant, so this is going to be negative sine of x. Okay, and then let's go and have a look at the cos. So we have cos of 90 degrees minus x, and this 90 degrees minus x speaks to something which you should have learned, which is called correlations. And all what you do, you convert your sine to a sine, you convert your sine to a cos, or a cos to a sine when you have 90 degrees minus x. So this means this here can be replaced with sine of x. So next, let's have a look at our sine of 110 degrees. Okay, so if you look carefully, this angle is just above 90 degrees. So this can be written as sine of 90 degrees plus, if you observe carefully, plus 20. And 90 degrees plus theta, you should remember that whenever you see 90 degrees plus theta, you should be aware that this is in the second quadrant. And whenever you're doing trig ratios, you convert from a sine to a cos, because at the same time, this is a co-ratio, not trig ratio. Okay. And we'll look carefully. We're converting from sine. So we know that sine is positive in the second quadrant. Okay. So we are saying 90 plus, which means we're just going to have cos of 20 degrees. Okay. That is what we end up having. So that is what we are going to have. And then let's quickly try and simplify the last bit, which is cos of 540 plus x. So if you observe carefully, you'll see that 540 is the same as 360 plus 180 degrees. So I'm going to have 360 plus 180 degrees. And then we have a plus x, like that. And you should know 360 plus any angle that gives us cos of whatever we have. So which means we just have cos of 180 degrees plus x, which ends up becoming cos. This here, you should be aware that you are looking at the third quadrant. And in the third quadrant, we know very well cos is negative. So this we can replace with minus cos of x. Okay. So let's go now and plug back and see what we end up obtaining. So wherever we see cos of 200, you can see we need to have cos minus cos of 20 multiplied by, wherever we see cos of 90 degrees minus x, we can have sine of x, then multiplied by, wherever there was tan of x minus 180 degrees, we end up having tan of x, okay, of which our tan of x, but let's maybe write it as tan of x first, and then wherever we have that cos of 540 plus x, we end up having minus cos of x, and this is divided by, wherever we have sine of 360 minus x, that ends up becoming minus sine of x. Then wherever we have sine of 10 degrees, 110 degrees, where is that? Sine of 110, it is up there, we end up getting positive cos of 20. Okay, so if you observe carefully, we can cancel a couple of terms. So the first one being this sine and this sine, and then secondly, we can cancel the cos of 20 and the cos of 20. Okay, and then what I can do is I can cancel one of the negatives. Okay, so I can say this negative maybe can cancel with that negative. So what then becomes left for our problem, if you observe carefully, it becomes, we have one negative, so you end up having a negative tan of x times cos of x. And we know that tan is the same as sine divided by cos. Okay, and then you are multiplying by that cos x. And there's going to be nice cancellation even on this one. So this will cancel with that, leaving our answer to be minus sine x. So this here becomes our final answer, okay, for that question 3.1. So I hope that you guys understand and you are able to make sense of all these steps that we undertook. So let's go to the next page and deal with 3.2. Okay, we're looking at that now. They are saying simplify without using a calculator this here. Okay, so let's go ahead. We're looking at 3.2. So we're given negative cos square of 10 degrees plus sine square of 190 degrees. And this is divided by, if you observe carefully, cos of negative 145 degrees, then times cos of 235 degrees. So what I always do on the side is to start by quickly simplifying some of these expressions here. And what I'm going to do first is to try and reduce the angles. And I want to reduce these angles to be below 90 degrees. Okay, that is my aim. So let's go ahead and start with one of them. If you look carefully, we have sine of 190 degrees there. So sine of 190 degrees, we know it's going to be sine of 180 degrees plus 10 degrees. So sine of 180 plus an angle that is the third quadrant, and sine is negative. So meaning we can have negative sine of 10 degrees in space of that sine of 190 degrees. Okay, then next we can go and have a look at cos of 235 degrees. Okay, and if you observe carefully, this will be the same as cos of 180 degrees plus. So if you think carefully, in order to make this 35 here, we need to add 55. Okay, and we know cos is negative in the third quadrant, so that means we're just going to have negative cos of 55 degrees. Okay, that is what we have. And we can now have a look at the other one, which is cos of negative 145. Well, what you should know is that whenever you have cos of negative an angle, it gives you the same as cos of the same but positive angle. Okay, now if you observe carefully, if we look at cos of 145, you will see that this is the same as cos of 180 degrees minus, it's going to be minus 35 degrees. Okay, or alternatively, what we could have done was to say this is the same as cos of 90 degrees plus. Now if you do 145 minus 90, you will see that the angle you get ends up being 55. Okay, and if you have such cos of 90 degrees plus 55, cos is negative in the second quadrant, so this means our answer becomes negative sine of 55 degrees. Okay, that is what we have. So now, all things considered, we have reduced this to a form that we can work with. So this means what we now have is negative cos squared of 10 degrees, then plus, if you observe carefully, sine of 190 we found as negative sine of 10 degrees. All of that is squared, and this is going to be divided by our denominator, that cos of negative 145. We end up finding that it should be negative sine of 55 degrees. Okay, then multiplied by that sine of 235. If you observe carefully, we end up getting it as negative cos of 55 degrees. Okay, now if you look at our numerator, you will see that we will end up having sine squared of 10 degrees and then minus cos squared of 10 degrees. Okay, and all of this is divided by, if you observe carefully, you will have your sine of 55 degrees times cos of 55 degrees. So when we are now at this point, we really need to remember two identities that will help us to simplify this even further. So I need you to remember the double angle expression for sine. So sine of 2x will always be 2 sine x cos x, okay? Which means if you divide by 2 on both sides, you will have that sine of x times cos of x is essentially the same as sine of 2x divided by 2. Okay, that is one thing I need you to remember. The other one is the double angle expression for cos, which is that cos of 2x, you should remember, can be written as cos squared of x minus sine squared of x. Okay, so this then puts us in two conditions. So since we have it the other way around, we can factor out a minus on the numerator and have cos squared of 10 degrees minus sine squared of 10 degrees. Okay, and then on our denominator, what we have there is just simply sine of 55 degrees, then times cos of 55 degrees. So we can now simplify this. So the numerator, we know, if you observe carefully, if you have x, you end up getting double. Okay, so this means that we will have cos of 2 times the angle we had there, that was 10 degrees. Then divided by, what we are going to have is, if you have a sine times a cos of x, you end up having sine of double. So that means we are going to have sine of 2 times the angle that was there, which was 55 degrees, okay? And this will be divided by 2. So let's see if we can create some space here. Try and simplify this. Okay. So if you observe carefully, let's just make space here. You will see that what we end up having is cos of 20 degrees divided by, if you observe carefully, sine of 110 degrees. And this will be divided by 2. Okay. Of which this, if you observe carefully, the 2 there will end up coming here. And you'll have cos of 20 degrees divided by sine of 110 degrees. For which 110 degrees we can simplify. Okay, 110 degrees, if you think carefully, that is the same as 90 plus 20. Okay, and we know how to deal with this. It's a trig identity that we call a co-ratio. So we'll have 2 cos of 20 degrees. And remember that sine is positive in the second quadrant, so with 90 plus. So when sine is positive, it means we convert to a positive cos of 20 degrees. And what will happen is this term and this term will cancel, leaving us with 2. Okay, so this means that entire expression simplifies to 2, and this here becomes our answer for this question. Okay, hope you guys understand. Let's move to the next question. 3.3. So we're here now. So let's go ahead and deal with this question. So with 3.3, what we are given is that we have cos of 40 degrees equaling square root of 1 minus p squared. So what I usually prefer to do is to always have a division by 1. How this is going to help me is the following. I know that cos is always given by the adjacent side over our hypotenuse. Okay, what does it mean? This means that I'm going to consider my adjacent side to be the square root of 1 minus p squared. Then I'm going to consider my hypotenuse to be 1. Now, if you think carefully, the only thing that is missing is our opposite side. And by Pythagoras, we should know that if you take your adjacent squared plus your opposite squared, you should get your hypotenuse squared. Okay, so we're looking for our opposite. So it means that our opposite squared, or our opposite, will just be the square root of our hypotenuse squared minus our adjacent side squared, of which, if you observe carefully, if you square the hypotenuse, it would be 1. Okay, our hypotenuse squared is 1, so that means we have 1 minus. When you square the adjacent, you just remove the square root, so it would be minus 1 plus p squared. And if you look carefully, your opposite will end up being p. Okay, now if we quickly draw a triangle, which is very important for you to always draw, so you should make a note that you should always draw your triangle. So let's quickly draw our triangle. So our triangle is going to be something like this. Let's give it a shot. So we are going to have a triangle like that, and we are going to have a 90 degrees angle. Then what you will see is we'll have 40 degrees. Then the other angle should obviously be 50 degrees. Okay, so with 40 degrees, remember our adjacent. So our adjacent should be here, 1 minus p squared. Then we have 1. Then our opposite, which is found to be p. Okay, with this now, you can go ahead and deal with all the other questions, 3.3.1, where they are looking for cos of 50 degrees. So cos of 50 degrees, if you observe carefully, you should be able to see that cos of 50 degrees is the same as sine of 90 degrees minus 40 degrees. Okay, sorry, cos of 50 degrees is the same as sine of 90 minus 50 degrees, of which what that means is that cos of 50 degrees is the same as sine of 40 degrees. But sine of 40 degrees, we already know the square root of 1 minus p squared. But even if you just went to cos of 50 degrees, sorry, if you were looking for cos of 50 degrees, which will become sine of 40 degrees. Yeah, so if you observe carefully, sine of 40 degrees, that would just be p over 1, which will end up being p. Okay, done with that. You could have read it straight from the triangle. So we can look at 3.3.2, where they're looking for cos of 70 degrees. But when we look at our triangle there, you will see that we have no 70 degrees there. So how are we going to deal with this? Well, if we really think about our triangle carefully, we can make the 70 degrees by using a special triangle. So if we say cos of 40 degrees plus 30 degrees, you will see that this one here, it works out. So what are you going to need? I need you to remember two things. The first thing I need you to remember is your special angles. Then the second thing, it is your compound angles, because we will need them here. Okay, so this cos here of 40 degrees plus 30 degrees can be written as cos of 40 and then times cos of 30 degrees. Let's create some space. And this will minus, if you observe carefully, it will be minus sine of 40 degrees and then sine of 30 degrees. Then for your special triangle, which is very important for you to remember, let me just squeeze it here. Sorry. Let's try your special triangle again. We have a 90 degrees there, very skewed one. But you should remember that with your special triangle, what you will have is a 30 degrees, a 60, and you'll have 1, 2, square root of 3. Okay, now let's go ahead and solve this. So this means that this cos of 70 degrees will end up being cos of 40 degrees. If you observe carefully, it is that divided by 1. So cos of 40 degrees is just square root of 1 minus p squared. Okay, then cos of 30 degrees, it is square root of 3 divided by 2. So it's square root of 3 over 2. Then minus sine of 40 degrees, it would be that p divided by 1, so it just becomes p. And then sine of 30 degrees, if you look carefully, opposite over hypotenuse, so that becomes 1 over 2. So we can finalize our answer, which is therefore, let's move it down, which is that cos of 70 degrees, this will be equal to, I'm just going to make a common denominator of 2. So it will be square root 3, square root of 1 minus p squared minus p. All of this is divided by 2. And this here, good people, becomes our answer. Very simple. I hope that you would have been able to get all these marks here for this question number 3. So the next question becomes question number 4, still part of this paper. So let's go ahead and solve this question. So we're looking at 4.1, where we are required to prove the identity above. Okay, so let's go ahead and see. So on the left hand side, we have sine of x plus 45 degrees. And this is divided by cos of x minus 45 degrees. And what we want to show is that this will end up being sine of 2x plus 1, all divided by sine of x plus cos of x all squared. So what I'm going to do is to just focus on the left hand side for now. Okay, and see what we can get done. So on the left hand side, we obviously need our compound identities. So it's very important that you do remember these. So just a quick reminder on them, which is that if you have sine of, let's say, a plus b, this becomes sine of a cos of b plus sine of b cos of a. Then for cos, because I can see it just below there, if you have cos of a minus b, what you will have is cos of a cos of b, then minus sine of a times sine of b. Okay, so what does this mean for our problem? Well, what it means is on the numerator, we are going to have sine of x multiplying cos of 45, and then plus sine of 45 multiplying cos of x. Okay, and this will be divided by our denominator, which will be cos of x times cos of 45, and then since there's a minus, we put in a plus, becomes sine of x sine of 45 degrees. Okay, and then your special triangle for 45 degrees is very simple, and you should be able to remember it. Let's undo that. So these you should know as you know yourself. You have 1 square root of 2, where you have 45 degrees here, 45 degrees here. So what you need to remember is your special triangle. Very important for this here. Okay, so, and if you observe carefully from your special triangle, you will see that your sine of 45 degrees, that will just be the same as 1 over square root of 2, and cos of 45 degrees, you will also see it is the same as 1 over square root of 2. Okay, so now let's go ahead and simplify the problem we have. So it will be equal to, we have sine x times cos of 45, which means we are just going to end up having sine of x all divided by square root of 2, and then plus, if you look carefully, we have sine of 45 times cos x, which will just end up having cos x divided by square root of 2, and all of this is divided by our denominator. Okay, and for our denominator, if you observe carefully, we have a cos. So that is just going to be cos of x. You're multiplying with cos of 45, which is just divided by square root of 2, and then plus sine. Let's have a look. Plus sine of x times sine 45, which is just going to be sine of x all divided by square root of 2. So if you observe carefully, you'll see on the numerator, if we pull out the common factor, what we end up having is sine x plus cos x. Okay, let's just create some space a bit. That is what we end up having. And on our denominator, we can factor out the common factor, which is 1 over square root 2. You'll see that we are left with cos of x plus sine of x. And if you observe carefully, you'll see that this and this will cancel, but also even this and that is the same. So we end up finding our left-hand side to be equal to 1. Okay, so on the left-hand side, we're getting 1. So let's now try and do something interesting, which is to simplify the right-hand side and see if we are going to also get 1. Okay, and if you observe carefully, for the right-hand side, what we have is sine of 2x plus 1 divided by cos of x plus sine of x all squared. Okay, and what I'm going to do is to quickly break that up. That's a double angle expression. So we'll have sine x cos x plus 1 divided by, if you quickly expand the denominator, well, let me leave it as is for now, sine x all squared. So what we are going to do is to quickly expand that denominator by doing FOIL. Okay, if you FOIL the two brackets, that are just going to be cos of x plus x, cos of x plus x, you'll end up getting cos squared x plus 2 sine x cos x, and then plus sine squared of x. So these two terms, we know that when you add them, you end up getting 1. So let me create some space here. Okay, so you will see that what we end up having is 2 sine of x cos of x plus 1 divided by these two here. When you add them, they will give you 1. Okay, so which means we end up having 1 plus 2 sine x cos of x. And as you can see, you can rightfully cancel this here and eventually get 1. So we can say, therefore, as you can see, our right-hand side is indeed equal to our left-hand side. Okay, so we're done with this problem here. So we can move to the next page. So this is our right-hand side. Okay, so they are indeed equal. Then we're going to go to 4.2. So with 4.2, this is what we are given, and we are required to solve for x. Okay, so for 4.2, there's something that I need you to be aware of, guys, which is that if you look at what we did here, we eventually found 1. So I just need you to remember, and I'll leave this as a comment. It's a very important question. So if you look at the sine of x plus 45 degrees divided by cos of x minus 45 degrees, what we found was that this is 1. So what does it mean? It means that this denominator, this sine of, if you think about it, x plus 45 degrees, as given here, it will end up being cos of x minus 45 degrees like this. Okay. That is what we are going to end up having. But now we need to think carefully. On one side you have a cos, and on another one you have a sine. So what I need you to remember is co-ratios. So what about co-ratios? This is what I want you to remember, which is that sine of theta is the same as cos of 90 degrees minus whatever angle that you had on the sine. Okay. Or if you have cos of theta, this will be sine of 90 degrees minus the angle you have on the cos, which is theta. So as long as these two angles, this one and this one, add up to 90, these will always be equal. Okay. So what does this mean for us? Well, it means the following. It means I can take cos of x minus 45 degrees and write it as sine of 90 degrees minus x minus 45 degrees, like that. So which means this cos of x minus 45 degrees can be written, if you observe carefully, as sine of 90 degrees minus x, then the other minus will end up adding with the 45 like that. Okay. Which means that our cos of x minus 45 degrees will end up being sine of this here 90 plus 45. It will end up giving us 135. So we have 135 degrees minus x. And guess what? This means that our sine of x plus 45, which was equal to this cos here, which that cos is now equal to that. So it is equal to sine of 135 degrees minus x. So guess what? Whenever we have trig ratios which are the same, we can just equate the angles. Okay. So therefore, you will see that we'll have x plus 45 degrees equaling 135 degrees minus x. So we know that our angles, they always have a plus 360. So we need to do plus k 360. Okay. And what we can do clearly is to move the x this side and then move this portion, this one, to that side. Okay. What does that give us? It means we now have x plus x equaling 135 degrees minus 45 degrees, then plus k 360. Okay. And you will see that we'll end up having 2x equals, if you do your 135 and you minus your 45 degrees, you'll see that you'll end up getting 90 degrees okay, then plus k, 360, okay. And then what we can do is to divide by 2 to be able to solve for this problem here. So let's go ahead and divide by 2, divide by 2, divide by 2. And you will see that our problem, x, it will end up being 45 degrees. Sorry, it will be 45 degrees plus k, 180 degrees. Okay. And if you look at our x, they said that x should be an element between 180, negative 180, and positive 180. So we're going to choose 2k values. So for k equals 0, you will see that we end up finding an x value that is 45 degrees. And then for k is 1, it's going to be outside this 180. So we can do for k is minus 1. Okay. So for k equals minus 1, what you will end up having will be just 45 minus 180, which will give you our x value to be negative 135 degrees. Okay, of which it is within that range. So that is what you were expected to do. But because we know that this trig ratio here really simplifies to 1, actually any x value, as long as it doesn't make the denominator to be 0, will work. Okay, just think about that. So it means that if we can get, let's say, cos of x minus 45, for this not to be equal to 0, then this will work out. Okay. So what we can do is we can force it to be equal to 0 and then exclude those values. What do I mean? Well, let's go and have cos of x minus 45 degrees and equate it to 0. And we can find our reference angle to be equal to cos is 0 when we have our angle being plus or minus 90 degrees. Okay. And what we can then do, you'll have x minus 90 degrees. Sorry, x minus 45 degrees. Equaling, for 1, you'll have 90 plus k, 360. K, of which you really don't need the 360 here. So it can be that one. And then when you transpose, you will see that you'll end up having your x value being. Now, if you observe carefully, you'll end up getting 135 as your angle here, of which with 135, you will clearly see that it is one of your angle. So x is 135 is one of the solutions that we end up getting here. Okay, and then we can go with the other one where we look at minus 90. So we have x minus 45 equals negative 90 degrees. And when you solve for your x, you'll see that you'll have minus 90 plus 45, which gives you x equals negative 45 degrees. So if you think carefully of all what is happening here, is that x can actually be an element of numbers, because remember that this and this, they are equal. So they'll be equal for all x values, if you think about it, except these ones that will result in a division by 0. So we can say that x is an element, if we want, from negative 180 to 180, and then say that x cannot be 135 degrees and x cannot be negative 45 degrees. Because if it becomes that, then we are going to have division by 0. That's very important. So that then brings us to the end of this question. And what we can say confidently is our answer is the following. Okay. So with this out of the way, let's go and have a look at 4.3. And remember, the part of ensuring we don't have division by 0 is very important, guys. So let's have a look at 4.3, where we are given that cos of 22,5 is A over C. So let's go and have a look at that. 4.3, we are told cos of 22.5, which what I'm going to do is I'm just going to write as an angle, okay, of which what this is just cos of 45 degrees divided by 2, okay, and this we are told it is A over C. And then what else we are told is that A squared plus B squared equals C squared. And then we are told with the aid of the diagram, or otherwise we should show what is happening below here. So let's go and have our diagram first. So, well, maybe the first thing that we need to note is that what we have here, this here looks like our Pythagoras. And remember that Pythagoras is true for your right angled triangles. So what that means is triangles that have a 90 degrees. Okay, so what we are going to do is to quickly draw a triangle and then work this out. So what is going to happen is the following. We are going to have our angle 22.5 degrees. We're going to have our 90 degrees. Then the other angle is just going to be 90 minus 22.5, which is going to be 67.5. Okay. And if we look at cos is the adjacent over the hypotenuse. Okay. Sorry, it is the adjacent, that is correct, over our hypotenuse, which is C, which means our opposite is just B in accordance to this equation. Right. Then what we are required to then show is what is happening there. So if you observe carefully, let's go ahead and have a look at it. We are required to prove the following, which is that 2ab divided by c squared, that is equal to square root of 2 divided by 2. And as always, what I'm going to do is to focus on the left hand side. Okay, so let's go ahead and do so. So what's happening on the left, we have 2ab divided by c squared. So what I'm going to do is I'm going to put the 2 here and then say a over c times, if you look carefully, b over c. This is how I'm going to approach this problem here. Okay, but I need you to remember, when we look at our triangle, that a over c, look at a over c, that is cos. So a over c is cos of 22.5. Okay, it's cos of 22.5. That is what a over c is. And then we can see we have b over c. If you look at b over c, that is a sine. So b over c, if you observe carefully, that is sine of 22.5. Okay, So it means for this problem, what we have is just 2 times sine of 22.5 and then cos of 22.5. And this here should ring bells because it looks like something which you should know by now. What is it which you should know? You should know that whenever you have sine of 2x, it is the same as 2 sine of x cos of x. Meaning if you have a 2 multiplying sine of x cos of x, you can just write cos of 2 times the angle you see on the sine in the cos. So this means we can have sine of 2 multiplying 22.5, of which that becomes just sine of 45 degrees. Okay, and you guys know very well from your special triangles that sine of 45 is just 1 over square root of 2. Okay, because if you look carefully for sine for 45, you'll always have 45 here, 45 there, 1 square root of 2. So you will see that sine of 45 will always be 1 over square root of 2. So which means our answer is 1 over square root of 2. But we can try and rationalize this here by simply multiplying by 2 over 2. Okay. What this does is not even 2 over 2. Let's multiply by square root 2 over 2. Like this, square root 2 over 2. So what you will see is that the denominator will end up being a 2. The numerator will have square root of 2. Okay, and that becomes your answer. And now you can clearly see that indeed our left-hand side is equal to our right-hand side. So we are very happy because at this point we would have gotten all the marks that are there to be gotten. So therefore, our right-hand side is equal to the left-hand side. So done with this question. Let's move on to the next one. And the next question is about circles. Okay, this is analytical geometry, still of this 2026 paper. Okay, so the statement reads, in the diagram below, the line PR, this is PR, with that equation is a tangent to the circle with center M at P. Okay, then they say the coordinates of M are 4 and 4. Great. Then they say PT, if you look carefully, PT is from here to there, so it's the diameter. PT is the diameter of the circle. V is a point on the tangent such that your V is a point on the tangent at T such that MV equals square root of 10. Okay. And then we are told to calculate the gradient of the diameter. Now let's think carefully of what is happening here. 2.1. So there's something that you should know. You should know that your diameter will always be perpendicular to your tangent. Okay, what does this mean? Well, it means the following. If ever you have any two lines, so let's say you have a line like this one, and you have another line like this one. You move them closer to one another, like that. If you find yourself in a position where you have the line A, B, C, and there's a 90 degrees, like that. So what you should be able to see is that AB is perpendicular to BC. Then when we talk about tangents, then the tangent of AB, because they are perpendicular, when we multiply it with the tangent of BC, what we should get is -1. This here is a very important property. So please make sure that you do know this property here. Okay. So if we look carefully, we can have PR. So if you look at PR, we have the equation of PR being y minus x minus 2 being equal to 0, which then gives us y equals x plus 2. So the gradient of PR is therefore equal to 1. Okay, but we know very well that PR is perpendicular. PR is the tangent. It is perpendicular to the radius, which is PT, or the diameter, which is PT. So what this means is that if I take the gradient of PR, I multiply it with the gradient of PT, which is the gradient of the diameter, I should get minus 1. Okay, so since the gradient of PR is 1, so that means I have 1 multiplied by the gradient of PT, which is negative 1. So you will see that the gradient of PT must be negative 1 for this to work. So we are done. We can therefore inform them that the gradient of the tangent equals negative 1. And that there is our answer for the first question, which is 2.1. Okay, next, let's go and have a look at 2.2. So with 2.2, we're required to determine the equation of the diameter. So we know that the equation of the diameter is negative x plus c, because m, the gradient, is negative 1. Now we need to figure out what is c. And to find c, we're going to use the coordinates of m, which are 4 and 4. So we'll put y as 4, then x as 4. And you will see when you transpose, you will find your c to be 8. So meaning our y becomes negative x plus 8. And this becomes our answer for 2.2. So this is our answer, which is our diameter equation. Okay, so I hope that this does make sense and you do follow. Very simple. So let's go to the next page in order for us to continue. Have a look at the next couple of questions. Okay, the next one is this one. So we're required to figure out what are the coordinates of P. Okay, let's have a look at that 2.3. So you should be able to see that at P, this is where our tangent meets, if you observe carefully, the diameter. So this means that our two equations must be equal. So if you remember our tangent equation, we found it to be y equals x plus 2. Our diameter, we just found it to be y equals negative x plus 8. So these must be equal. So what this means is we'll have x plus 2 equaling minus x plus 8. So we can transpose this and transpose that. So what we end up having is x plus x equals 8 minus 2. So we end up getting 2x equaling 6. And we can now do our division by 2 on both sides. Just quickly do that division. Divide by 2, divide by 2. And you will see that the x value that we end up finding is 3. Okay, and now that you have your x value as 3, you can go ahead and use one of these equations to be able to find the y value. So use one of the equations to find y. So what we are going to do is we are going to use the tangent one. So y is going to be, if you look carefully, x plus 2. So we're just going to sub in x is 3, which means we'll have 3 plus 2, which will give us a 5. So therefore, the coordinates of P we have found. P will have an x value of 3 and a y value of 5. And there we go, guys. That becomes our answer. And whoever is marking for you should be very happy. Okay. So done with that, let's go and have a look at the next one, which is looking at 2.4. So with 2.4, they are saying determine the equation of the circle in that form. Okay. So remember, whenever we are looking for the equation of the circle, we need two things. So the first thing which we need is our radius squared, essentially r squared. And then the second thing we need is our center. In this case, we have it is at point M, 4 and 4. So we just need to find the radius, and that would be it. So let me create some space here, and we see if we can squeeze the radius here. Right. So if we try and find the radius, you'll see that our radius squared is essentially the distance between, if you look carefully, from M to P. Okay. So what is that? So from M, we have an x value of 4. So we're going to say 4 minus 3, which is at P, all squared, minus, and then we do the y. The y at M is 4, minus the y at P, which is 5. And if you observe carefully, you have 4 minus 3, which is 1. Then 4 minus 5, which is going to be negative 1 all squared. So our r squared is going to be 2. Okay. So this means that we can now write the equation of the center of the circle, which is going to be x minus 4 all squared plus y minus 4 all squared equaling 2. Okay. So that becomes our equation of the center, and that becomes our answer. Very simple. You just needed to calculate the radius, and yeah, this would have worked. Okay. Done with that, let's go to the next page and see how can we find those coordinates of t. So we're looking at this here. Okay, so let's go ahead now and have a look at this question where we are required to calculate the coordinates of t. So we need to think carefully of... So in order for us to figure out the coordinates of t, 2.5, what we are going to do is to use the equation of the circle. So we are trying to figure out what the coordinates of t are. And if you remember, the equation of the circle is x minus 4 all squared plus y minus 4 all squared, and this equals 2. Okay, but remember that we have an equation which is the equation for PT, the diameter, which is y equals negative x plus 8. So you should be able to see that at point T and P, the equation crosses the circle. Okay, so meaning what we can do is we can take our y and plug it into that to solve for the x, then solve for y. Sorry about that, guys. What I did was to just blow my nose and then I ended up, nose bleeding. So my apologies for the language. Okay. So let's go ahead and, well, for this one, this then becomes our answer for question 2.5. So let's go to the next page, guys, and see how we can solve this problem. So the problem we're looking at next is problem number 2.6, where we are required to figure out what is the length of VT. Well, what I want to remind you is that the radius or diameter is always perpendicular to the tangent. And remember, the distance from here to there, we know it's going to be the radius. And our radius squared is 2, which means the distance is just square root of 2. So all what this means is the following. It means we have a simple triangle that we need to deal with. And this is for 2.6. And that triangle is M, and then it has a T. This length here is square root of 2. And we have a V here, and this was given to be square root of 10. Okay. And what we are trying to figure out is what is VT equal to. So according to our Pythagoras theorem, you'll be able to see that our VT will simply be equal to, or VT squared rather, it will be VM squared minus MT squared, okay, of which our VT squared will be our VM, that is square root of 10, all squared minus, if you observe carefully, our MT, that becomes just square root of 2, okay. So our VT squared becomes 10 minus 2, which becomes 8, which means our VT will just be square root of 8. So it will be square root of 8 units. Okay. And this for 2.6 becomes our answer. Okay. So one of my nose is blocked, guys, but let's carry on anyway. So that is our answer for 2.6. So let's think about 2.7. So let's have a look at 2.6. Sorry, it is 2.7 now. So we're looking at 2.7. So we are told if the equation for VT, well, let's quickly note it down, which is that the equation for VT is y equals x minus 2. Okay. It is that. Then they say for which k values will y equals x plus k not be a secant. Sorry, for which values of k will x plus k not be a secant to circle P? So what I think happened there is they probably meant circle M, because with circles we refer to them using the center. So here I'm going to take a guess that what they meant was circle that is centered at M. So remember our equation PR, what we found, or we were told that it is x plus 2. Okay. So if you think of it carefully, for any k value that is between, if you think of what is happening here, just need you to use your imagination. What you have is minus 2, then what you have there is 2. So if we have any k value that is in between these two, our secant will definitely, or our line will be a secant, meaning it's going to cut. So our line will cut. So if you observe carefully, for k values, for k is an element of, we need to exclude of minus 2 to 2, then what we will say is that y equals x plus k is a secant. As long as the k value is between minus 2 and 2, then this will be a secant. Okay? Or alternatively, we can say or, which is our answer. Okay? We can say that for this y equals x plus k, this is a secant when the two conditions are met. Okay? So when k is greater than 2 and k is less than minus 2. So meaning if the k value is somewhere here, then that will not be a secant, is not. So is not a secant under these two conditions. Okay, and that is what really they were looking for. So they said for which will not be a secant. Yes. So that is what is happening. Okay, so I hope that this does make sense to you guys. And then we can now have a look at the last question, which is 2.8. That is 3 points. But what I'm going to do is probably leave that for you as homework. So, but it reads, second circle centered at 1 and 1, at 1 and 3, and with radius q, it touches the circle with center M. Determine the values of q. So for 2.8, let this be your homework. Let's see what you get. Okay, go and try this as homework, and yeah, share your answers on the values of q which you found. Then the next question is this one, question number 6, which reads, in the diagram below, a lamp post Ly placed at the corner of a triangular field, which is XYZ. Then we are told the area of the field, is a meters, or is a meter squared, and we are given the angle as seen there, and we are told all the other parameters. And then now we are told we need to determine YZ. So let me see. We need to determine YZ in terms of A, P, and 2 theta. So YZ should be very easy for us to figure out here, 6.1, because we are going to use what we call the area rule for this. Okay, if you look carefully, if we look at the area of triangle XYZ, you will see that it will be half of, we will use two sides, so we'll use XY multiplied by YZ, and then sine of, if you observe carefully, X angle Y, Z. Okay, that is just the definition of the area rule. I need you to go and revise it if you are confused, but essentially we need two sides and an included angle. But the area we already given that it is A, so that means we are going to have A equals, we are going to have half of P multiplying your YZ, and then sine of the angle 2 theta. That is the included angle. So if you observe carefully, we can now divide this here. Therefore, you will see that our YZ will be A divided by half of P and then sine of 2 theta. Okay, of which this can be simplified. The 2 we can push it up and it becomes 2A divided by P sine of 2 theta. So that is what our YZ becomes. Let's copy this and let's paste it here. Okay, that is what our YZ becomes, and this will be in meters. Okay, done with that. Then let's go and deal with 6.2. Very easy problem. Then they say, hence show that the length of the height of the post, which is Ly, it's going to be given by that. Now, let's think carefully about Ly. So if you look at Ly, just going to draw this triangle here. You have 90 degrees. And then you have L here. You have Y, and then you have Z. Then you have theta here. So remember that YZ, which is found now to be 2a divided by P sine of 2 theta. So what you should be able to see, since we're looking for Ly, is that if you do Ly, or if you look at sine, not sine, but tan, my apologies. If you look at tan of theta, you will see that tan of theta will be Ly divided by YZ, which means that your Ly will simply be YZ tan of theta. So which means our Ly, which is what we are looking for, will be our YZ, which is 2a divided by P sine of 2 theta times tan of theta. So what I'm going to do is to express this in their respective angles. Just split them apart. So we'll have 2a divided by, we'll have P into, this is a double angle expression. So I'm going to have 2 sine of theta times cos of theta. Okay. Then times, if you look at tan we know it's sine of theta divided by cos of theta. So if you observe carefully, you will see that the signs will cancel here. Okay, let's create some space and see how this can simplify further. So the signs will cancel, but you should also note that you have 2's that will cancel. So this then leaves our answer to be a divided by P into, you have a cos and a cos. So it becomes cos squared of theta. So therefore, we can just write our answer a bit neatly. You'll see that our y becomes a divided by P cos squared of theta. And this is exactly what they found. So this here becomes our answer. So I hope that you do understand, and this gives you a smile. It's a doable question. You just had to apply yourself. Okay. So let's go and have a look at 6.3. So at 6.3, they give us the P, they give us YZ, and then they say we should calculate XZ. Okay, let's have a look at what is happening. So 6.3. So we're looking for XZ, and they also gave us theta. Okay, so the first thing that I'm going to do is to find all sides that can be found and the angle. Okay, so if you look carefully, XY, which is P, that becomes just 15 meters. Okay, and then if we look at YZ, if you remember, was this, all of this. So it means we are going to need to sub in all of that. So let's go ahead. Our YZ, we are trying to calculate what XZ. So this is going to be, we're given the P, while YZ has been given as 30. Okay, that makes our life to be very easy. So they give us YZ to be 30 meters. Okay, and now if you observe carefully, we have 2 times the angle, which is 2 times 60 degrees, which becomes 120 degrees. So all what we now have, if you look at the problem, we just have a simple trigonometry problem now, where the angle that is sitting here is 120 degrees, and you have Y, and you have X, and you have Z. This one here, X, Y, Z, has been given as 30 meters. The other one has been given as 15 meters. Now, if you observe carefully, this is what we are looking for. And what you should be able to see is that we should use the cosine rule, because we have 2 sides and an included angle. Very simple. So we should have xz squared equaling, we are going to have 15 squared plus 30 squared minus 2 times 15 times 30, and then cos of 120 degrees. So we'll do cos 120 degrees. Okay, so our xz all squared will end up being, so I'm just going to go to my calculator and quickly punch this. So 15 squared plus 30 squared minus 2 times 15, 30, and then cos of 120. Okay, so what I end up getting is 1575. So I know that my xz will just be square root of this 1575. So square root of answer. And what we end up getting, this is units. We end up getting our xy as 15 square root 7 units, which we can round off to 2 decimal places. So let's see. We end up getting our xz to be 39.69. Well, there's no need to use units. This is in meters. Okay, so let's just say meters, meters, and meters. So that is what they were expecting us to do to get this 8 points here. So I hope that you guys, I hope you understand, and you could possibly get all these questions correct. Okay. Then question number 7, which is very standard and everyone should have gotten these marks here. They want us to show that the angle that is here, 2 times m, is the same as the angle that is here. So essentially for this one, what you needed to do was to just construct a straight line like this one. Very simple. Okay. And what we can do, we can go ahead and deal with this from here. And you should be aware that what we have is the radius here. So this and this, they are equal, and that they are equal. Okay. So what do we mean? Well, there's a couple of things we need to note. You need to note that we're looking at 7.1. So you will see that these lines, I'm just going to put that up. So our MO is equal to NO, which is equal to OR. Why are these equal? It is because these are the radius. Okay. So whenever you have a radius, you will see that it will make an isosceles triangle. So if you look at O angle N, O angle NM, that will be the same as O angle MN. Okay? And if you observe carefully, these are base angles of an isosceles triangle. Okay? What makes that triangle to be an isosceles? Well, the triangle we are speaking about, or one can say here, angles opposite equal sides. Okay? So someone else would have said angles opposite equal sides. Okay. Then even on the other triangle, you will see that ORM, that angle will be equal to OMR. And this is angles opposite equal sides. Okay. This is very easy for you to figure out. These angles are equal. But then what you should notice, I'm just going to say we have O1 and O2 like that. So what you should then notice is that the angle O angle N, O angle N M plus O M N, these angles will end up giving you angle O2. Okay? And if you observe carefully, these angles are equal. So meaning we have 2 times O angle MN equaling angle O2, because these are equal. Why is this the case? This is the exterior angle of a triangle. Okay, then if we look at the other ones, you will see that this O angle RM plus O angle MR, this will end up giving us angle O1. And why is this the case? It is the exterior angle of a triangle. But we know that these two angles are equal because they are angles opposite equal sides. So this means that what we end up having is OMR. We'll have 2 of it equaling angle O1. Okay. And then what you will see, 2 times OM1. But what you will see is that angle O1 plus angle O2, these ones, they give us the angle that is called NOR. Okay, so meaning if we have 2 times OMR plus 2 times, if you observe the other one, OMN, what we have is this NOR angle. But we can factor out something here and be left with OMR plus O angle MN. And this becomes NOR. But if you look at what is happening here, is you are just adding this angle and this angle. And that entire angle, if you observe carefully, just becomes NMR. Okay, or angle M as a whole. So you'll see that what we end up having is 2 times angle M, that will end up being NOR. Okay, and this is the end of it, because what is purple is what led to this here. It is just angle M. So this here would be your answer. Your proof would be finished at this point. Okay, so if you observe carefully, that is just about what you were expected to do for that 4 points. So let's go and fetch this question and quickly see what they were expecting the guys were writing to be able to do. Okay, so let's go ahead and have a look. So you will see that we are given this figure here. Let's make it slightly smaller. And a statement that reads, in the figure below, O is the center of the circle passing through A, B, D. Okay, and then we are told AC is a tangent and BD is produced to meet the tangent at point number C. And we are told the ratio of CD and CB, so CD and CB is 1:4. Okay, and then we are required to prove that such is the case. So let's go ahead and work out what is happening here. So the first thing that I'm going to do is to quickly mark angles that are equal. So this angle here is equal to that one, okay? And then this angle D2, angle at the center, or angle in a semicircle, that will be 90. And then even this one will be 90. Because angles on a straight line should add up to 180 degrees. And then this angle here will end up being equal to that angle by the virtue that it will be the third angle. Okay, so which means here you're looking at triangles that are similar. So we can play and put sides, such that they divide in proportion. Okay, but let's deal with the angles. So 10.2. So what we need to do is to prove similarity first for us to be able to do this. So what you will see is that angle A1 is equal to angle B, and the reason should be tan chord theorem. Okay, and what you will see, so let me just put this. So this would be triangle ABD being similar to triangle ACD. Okay, that is what we are trying to show here. So if you observe carefully, so yeah, let me just switch these around. So just move that. Okay, so if you look at that, that is the case. And if you observe carefully, you'll see that our D2, angle D2 would be 90 degrees. Okay, then this would be angle in a semicircle. Okay, that's the reason. And then you would know that your angle D1 plus D2, that should be equal to 180 degrees, and this is angle in a straight line. Okay, so which means we are going to have D1 plus 90 degrees equaling 180, which means therefore D1 will be 90 degrees. Okay, so we now have D1, then the other angle, they will be equal. So angle C will just be equal to angle A2. And the reason is you can always say third angle. Okay, two angles in a triangle or in two triangles are equal, then the third angles will also be equal. Okay, now with this in mind, we can go ahead and solve this problem here. So what we are told is that CD divided by CB, that just gives us 1/4. Okay. Now what we are required to do is that if CD is X, then we are required to prove that. Now let's think of what is happening. So if CD is X, if our CD is X, then for this to divide accordingly, it means our CB must be 4X. Okay, that is what it means. So it means what we have here is X, and then what we have here is simply 4X. Okay, and then let's just go and see how we can deal with this. Now we are required to figure out what is AD squared. What is it equal to? Okay, and this should be very easy to figure out because look at where AD is. So AD is in between these. And what we need to do is to put them proportionally. Okay, so what we are going to do is I'm going to look at the blue angles as an example. And then what I'm going to do is if you observe carefully, there's AD. So I'm going to do AD divided by, now I'm going to go to the smaller triangle, that will be CD. So it will be divided by CD. Okay, then let's go to pink. So with the pink angles, you will see that in the bigger triangle, I'm opposite to, sorry, no, I'm labeling the wrong thing here. Where is CB? CB is this entire length. Okay, so CB is this entire length, that should be 4X. Therefore, if you observe carefully, this here should be 3X. Okay, yeah, I hope you can see. So if we look at the pink ones, you will see that we will have DB. So we'll have DB divided by the smaller triangle, the side opposite. That one would be AD. Okay, so AD, then this will be equal to, let's go for the purple ones. So the purple ones are opposite to the bigger triangle, is AB. Then on the smaller triangle, what is opposite to 90 degrees is AC. Okay, but if you look carefully, we're interested in the part that has AD. So this means that our focus is just going to be on this one. Okay, so that is where our focus is going to be. So if you quickly cross multiply this, you will see it will simplify. So let's cross multiply. So if you cross multiply, you'll end up having AD multiplied by AD equaling CD multiplying that side, CD multiplying DB. So you'll see that you'll have AD squared equaling CD, if you look carefully, that is X multiplied by DB, you will see that that is 3X. So therefore, if you look carefully, your AD squared will simply be 3X squared. And this here becomes your answer. Okay, I hope that you are able to follow here and you understand all the steps that we undertook. Very simple problem. You should be able to get it. And this here we are doing because the two triangles ACD, it is similar to the other triangle ABD. Okay, that is why we are able to put these sides in proportion. Hope you guys understand. Very easy question. So what you can do is you can go out and try this question, which we will do as part 2 of our lesson. So go and try this out. and see what you do obtain for it. Okay, this is a trick question where you are required to write down the amplitude of G. If you look carefully what G is, but maybe let's just ace it. Yeah, let's ace it. Change of thought, guys. 5.1. So if you look at the amplitude of G, look at G. What is multiplying cos there is 1. Because if you look at G of x, you will see that you have cos of 2x. But what is sitting here is just 1. And that 1 is our amplitude. Okay. So we can therefore say that our answer for that question is 1. Okay, and then let's go to 5.2. So in 5.2 we are required to write the period of G. Okay, so what I need you to remember is the following, which is that if ever you have a trig ratio, let's say you have cos of ax, how we find our period is affected by the a. So your period becomes 360 divided by a, okay, of which in our case, our g of x is cos of 2x. So therefore, we can go and look at our period, which will be 360 for cos and sine, divided by whatever number that is multiplying x, which ends up being 180 degrees. So here, we can therefore write our answer, which is that our period is 180 degrees. Okay, that is what we have. Then let's go ahead and have a look at 5.3. So for 5.3, we are required to write down the range of G. So remember, when we are looking at the range, we are looking at y values. Okay. So if you look at our function G, which is the cos one, you will see that it will oscillate between 1 and -1. Okay. So what we can do is we can therefore say that our range, which is just y, it is an element, it is an element between -1 and +1. Okay, it's between -1 and +1. Someone else would have said, or they would have said y is between 1 and -1, like this. Okay, and this would still be very much correct. So done with that, let's have a look at 5.4. So they are saying determine the x values for which we have these conditions here. So I'm going to go to the next page for this one. Right, let's have a look at 5.4. And we look at 5.4.1. Right. So for this one, it's just interpretation of the graph. So they want where the product of these two, and this is between -90 and 180. Okay, so yeah, it's just what we see here. So from here up until there. Okay, so we are then asked to figure out where is it where when we multiply the two graphs we get -1. So let's think carefully. What you should be able to see is that the tan graph is -1 here, and the other one is +1. So we can clearly see that this is happening at x is 0. So at x is 0, it is happening that the multiplication becomes that. Okay. So that is what we end up having. But also, you must look carefully, look at 180. Okay, so at 180, you will see that one of the graphs is at a positive 1, which is this one. The other one, if you observe carefully, it is at a negative 1. So it is at x is 0 and at x equals 180 degrees. And that is how you get the 2 marks. Okay, now let's go to the next question, which is 5.4.2. So they want a case where our tan of x is equal to cos of 2x. Okay, so let's have a look where our tan of x equals cos of 2x minus 1. 2x plus 1. So what I'm going to do, I'm going to transpose so that we actually have the tan of x minus 1 equaling cos of 2x. And if you look carefully, this just becomes when, for what x values is f equal g. So where are they equal? Now, if you observe carefully, they're at 90. No, that is not 90, that's at 45 degrees. So let's have a look at our solutions. Where these are equal, you will see that they are equal at x equals 45 degrees. That is where they intersect. And they don't intersect anywhere else. Okay, at least within the given range. So where you were going to get marks was for you to realize that this is what we are working towards. And this is the answer here. Okay. Awesome things, guys. So let's move on to 5.4.3. So this is what we are asked. So if you observe carefully, there's a couple of things that we should be able to figure out there, which is that we have 2 minus 2 sine squared x being less than or equal to tan x. So if I make this to be 1 plus 1 minus 2 sine squared x being less than tan x, what you will see is a couple of things. That this identity here is cos of 2x. Okay, so this means what we have is 1 plus cos of 2x being less or equal to tan. So we can transpose this one here such that we have cos of 2x being less than or equal to tan of x minus 1. And do you see that this problem is simplified to our functions? Okay, so it has simplified to, if you observe carefully, for what x values is g of x less than f of x. Okay, so our f of x is the tan graph. So when is it above the cosine graph? Okay, that's essentially the question. So let's create some space here. Right, and if you look carefully where the tan graph is above the other one, you will see that it would be for x values that are, let's have a look. In this case, it is just between, it's just from here to there. That is the only time when this graph is just above the other one. And remember that it is approaching our tangent, and the tangent of this graph is at 90 degrees. So essentially, this just becomes x is an element from here up until, we reach there. So what this means is that our solution is going to be this. solution from 35 up until 90, but excluding 90. So we have greater or equal to, so it will be x is an element from 45 degrees up until 90 degrees, but we must exclude the 90. Okay, and that becomes our answer. Our graph G would be at the bottom, the other one would be at the top. Okay, hope you guys understand. This one here becomes our good answer that should make you to smile. So we have covered most of the paper. For today's lesson, we'll pause here, and I need you to be on the watch for part 2. So make sure you are on the watch for part 2. And this lesson, guys, is brought to you by iCampSA. So please like, share with friends, and subscribe to the channel. I hope that you did find this lesson very helpful. So please do share with others and use this as an opportunity to learn, prepare for your exam, prepare for your prelim and also your final exam. Cheers, guys. Take care.